This video covers sections 2.4 and 2.5 in your text. We're going to specifically be talking about percent equations, proportions, and inequalities. And the first thing we're going to talk about in section 2.4 is the idea of the basic percent equation. And I know percents are sometimes scary to people, but once you get the hang of them, they're really not that bad, so try to keep an open mind. The percent equation itself looks like this: percent times the base equals an amount. And what we got to remember is what percent means. If you break it down into parts, this last part, the cent, means 100. So what this really means is per 100. So out of every 100 free throws you make, what if you made 70% of your free throws? That means you would make 70 out of every 100 free throws you took. If you got 20% off on a sale at a store, that means for every $100 you spend, you would get $20 off. So percent means per 100. And so when we're trying to find the percent of something, we're always trying to find the percent of the base, but we have to remember that the base is actually the total. That's, if we're talking about the free throw problem, that's the total number of free throws taken. If we're talking about a sale, that's the total amount that our purchase was before the discount. So I wrote right after that, we're usually trying to find the percent of the total, or the percent of the base. Another important thing to remember here is that multiplication a lot of times gets translated into English as the word of. So when I say percent times base, that's like percent of the total. And then one last thing with the percent equations, we should always try to write a percent, or not try to, we should always write the percent as a decimal value. Remember, we did this a few sections ago. When you're writing a percent as a decimal, you just move it over 2 places. So, for example, 84% equals 0.84. We move that decimal place 2 places. So it would be in front of the 8. So here we go. 84 is what percent of 175? So now you could here jump right into just straight translating this to an equation in math. This is an equation in English, but look what this says. 84 is equals, okay, what percent? Well, we don't know this. This is our unknown. So a lot of times we use X for unknowns. And then of means multiply 175. Let's write that a little cleaner. 84 equals X times 175. Or might look better if we said 84 equals 175 X. One thing I want you to notice, though, is that this equation right here is essentially the percent equation we wrote above. The only thing is that the amount, this part over here on the right, is on the left in this case. But it's still a percent times the base, or the total, equals the amount. And we're trying to find what the percent is in this case. That's what the X is. Going back to solving linear equations, remember, if we want to solve for X, which is multiplied to the 175, it's married to it, we divorce. So we divide by 175, and you can use your calculators for this calculation. You should get that X is equal to, what do we got? I got 0.48. Remember, this is a decimal, but if we want to think of it as a percent, move the decimal place back 2 places to the right, so that's 48%. Another one. 40, and we're just going to translate it. 46 is what? It's equals 40%, but as a decimal that would be 0.40 of, multiply what number? That's what we don't know. That's our x. This is 0.4 times x, so to solve for x, we just simply divide. Divide by 0.4. So 46 divided by 0.4, again using your calculator, is going to be 115. X is equal to 115. Okay, and then one more here. What is, so we don't know, we're going to start off with x here at the beginning. So what equals, what equals, x equals 22%, or 0.22 times 70. There's no solving needed here. We can just plug that into your calculator. 0.22 times 70 is equal to 15.4. Okay, so that's the basics of working with percent equations. Remember, we're always taking the percent of a total. We always have to write the percent as a decimal. These problems, not that interesting, but we do need to just talk about the basics of a percent before we get to class. When we get to class, we'll start to talk about some applications of these and some problems that are a lot more interesting. Next, we're going to move on to ratios and proportion. So the first one is that a ratio, definition here, a ratio is a quotient of two quantities with the same units. For example, 5 gallons to 10 gallons. Whereas a proportion is a statement that two ratios are equal. So you might have something like 1 over, or let's actually come back here to the previous example. 5 gallons over 10 gallons is the same as 15 gallons over X gallons. So that might be an example there of a proportion and a ratio. All we're really going to worry about in this video is how to solve them. So I have two examples here, and what we're going to use is this property here in parentheses. What you'll see is that if I have a proportion here on the left, A over B equals C over D, it gets rewritten as A times D equals B times C. And there, what we call this is a cross product. A times D equals B times C. You may have done this before. So what we're going to do is we're going to take 18 times 180 on one side. 18 times 180 is equal to, and then we take the other cross product, 40 times n. And 18 times 180 is what? It's 3,240 equals 40n. Multiply, marry, divide, divorce, divide by 40. 3240 divided by 40 equals 81. So I have an answer here of n equals 81. Not too bad. The next one's a little bit more complicated. Still, it's the same concept though. We take 3 times 28, write that on one side of the equal sign, is equal to 4 times n plus 12. And when we multiply by n plus 12, we have to put that in parentheses because there's two terms there, which means we will have to do what? We will have to distribute. 3 times 28 equals 84. And then if we distribute, we get 4n plus 48. Now this is a two-step equation. I have the n's already on the right-hand side, which means the 48 then needs to go to the other side. This is a positive 48, so if I move it over here, it becomes a negative 48. We'll go ahead and move it. 84 minus 48 equals 36. So that's 36 equals 4 times n. Divide divorce. Divide by 4. Divide by 4. And we get our answer. We get that n equals 9. Okay, so that's how we solve proportions. Again, just like with the percents, we're going to look at some more interesting applications of these in class. We're not going to do that on the video. Okay, this takes us to our last section, section 2.5, which is linear inequalities. You may or may not have seen this before, but we're going to basically review what you know about the number line and graphing in linear inequalities on a number line, but then we're also going to introduce something that's probably new to most of you called interval notation. So just starting out with a number line real quick in inequalities, if I am graphing a linear inequality on a number line, then the first thing I need to know is about what kind of symbols we use if we have greater than or less than versus greater than or equal to and less than equal to. So if we just have a less than or a greater than, we are going to use open circles. Versus if we have a less than equal to or greater than equal to, we are going to use closed circles. For example, if I wanted to graph x is greater than or equal to negative 3 on a number line, the first thing I would do is I would find negative 3. And notice since this is a greater than equal to, I'm going to use a closed circle there. And that is greater than. That's greater than negative 3. Which means I'm going to graph every number, I'm going to graph in the direction of the numbers that are bigger than negative 3, which would be the numbers to the right. Okay. We have another example. Graph the solutions of x is less than negative 5. Notice here there's no equal to, so I'm not going to use a closed circle this time. I'm going to use an open circle at negative 5. And now it's less than, this is less than, which means we now shade to the left instead of to the right like before. Okay. So what I would like you to do here is go ahead and pause the video, and while you have the video paused, go ahead and try to write out the number lines solutions to each of these 4 inequalities, and then we'll come back and talk about what interval notation is. So again, go ahead and pause the video and write down what you think the answers are. Okay, welcome back. Hopefully you were able to come up with these answers that I have showing here. Notice that this is less than negative 2, so that's shading everything to the left, and because it doesn't have an equal to there, it's an open circle. The next one has equal to, so we have a closed circle at 3, and this is greater than, so we shade to the right. The next one may be new to you. This is called a compound inequality. That means there's two of them in it, or a double inequality. And in this case, notice that x, the values of x, are sandwiched in between -6 and 5. They're greater than -6 yet less than 5, which means the shading is between those two numbers. There's a solid circle at -6 and an open circle at 5. And then lastly, x is less than or equal to -6. That's a closed circle there at 6 and shade to the left. Now, interval notation is just a way of representing what we see on the number line in a more compact form, I like to say. So let's go back up here to my 4 little notes here. The first note is that you always go from left to right on the number line when you're writing out your interval notation, just like we read a book, left to right. Also notice that we use brackets when we have equal to, and we use parentheses when it's just less than, greater than, without the equal to. And then we always use parentheses for infinity or negative infinity. Now the concept of infinity and negative infinity is that, you know, on the number line, we always go out to the right. In fact, let's come back up here to our big one. 0 is right smack dab in the middle. But out to the right is the positive numbers, so we could think of, if we just continue out forever, that would be positive infinity. And then if we go to the left, we have negative numbers, and if we continue to go that way forever, we approach negative infinity. So, if I look at this first example, this shading, this red shading, is going out to positive infinity or negative infinity. Well, since it's going to the left, it's definitely going out to negative infinity. So we can think of this as like negative infinity out here. And remember, we always go left to right. So what we see here, if I start on the left and go to the right, what I see is negative infinity to -2. So I'm going to go ahead and write that. Negative infinity to -2. And you always separate those by parentheses. And then we're going to go ahead and, for the negative infinity, remember negative infinity, we always use parentheses. So on that side, we're going to have parentheses. And then on the other side, the -2 side, it's an open circle, which means that it was, remember, it was less than. So anytime we have less than, that's right here, we use parentheses. So all this interval notation is saying is that your answer is everything from negative infinity to -2. Negative infinity to -2. Let's do another one. This time the shading doesn't go to negative infinity, it comes out here to positive infinity, and moving left to right, it would go from 3 to infinity. So we go 3, comma, infinity. And then the 3, this case we do have an equal to, it's a closed circle, which we use a bracket there. And for infinity, remember, we always use parentheses. Notice these first 2 examples. Parentheses always on the infinities. Third example, there is no infinity. It's between 2 numbers. And moving left to right, it goes from -6 on the left to 5 on the right. So I'm going to go ahead and write -6, comma 5. It's a closed circle on the left, open circle on the right. So it's a bracket, parenthesis. It's an equal to and without an equal to. Bracket, parenthesis. We might even make a little note up here. Brackets are when we have closed circles, parentheses are when we have open circles. So on the last one here, this is going out to negative infinity. Moving left to right, it's negative infinity to 6. Negative, oops. It's a terrible looking negative infinity. Negative infinity to 6. Always use parentheses on the infinity, and because that's a closed circle, this is a bracket. So that's interval notation. When solving linear inequalities, it's always the same as when you solve an equation, except for when you multiply and divide by a negative. Whenever you multiply or divide by a negative, you have to, oh, and there's a little typo there, that should be just T0, TRTO. You have to switch the orientation of the inequality symbol. So we have to do that in this first example. If I was going to solve this, just like we've been solving equations, we want to get the x's on one side, numbers on the other. So I'm going to need to move this positive 7 to the other side, which makes it a negative 7. If I move it, change sides, change signs. So this is negative 5x coming down, greater than, bring that greater than down. 32 minus 7, 25. Okay, this x is married to the negative 5 by multiplication. Multiply, marry, divide, divorce. So I have to divide by negative 5, divide by negative 5. That cancels those. But now here we go. Notice we divide by a negative. Divide by a negative. When that's the case, we have to switch this to a less than. We have to switch it from a greater than to a less than. So that becomes x is now less than negative 5. Okay, if I draw that on the number line, negative 5, less than, that's an open circle. And I'm going to shade to the left. So this is approaching negative infinity over here. So when I go to write in interval notation, left to right, that's going to be what? It's going to be negative infinity to negative 5, parenthesis or bracket with infinity, negative infinity, parenthesis, and because that's an open circle, parenthesis. We're going to do one last example here with a double inequality. And double inequalities are kind of cool because you're still solving an equation the way you normally would, except you're solving two equations or two inequalities simultaneously. So the principles still apply, except that when you do it to one side, when you get x by itself in the middle, we need to isolate x in the middle. When you do that, you also have to do it on the outside in both places. So if I want to move this 8 out, if I want to subtract 8, I have to subtract 8 everywhere, on the left, in the middle, and on the right. So cancel there. Negative 10 plus a negative 8 is a negative 18. It's a negative 18. 3x is in the middle, and 6 on the right. We could divide everything by 3. We got to divide by 3 to get x by itself, but if I divide the middle by 3, I have to divide the left and right by 3. So doing that, negative 18 divided by 3 is negative 6, is less than x. 6 divided by 3 is 2. If I graph that, I have negative 6 to 2. Those are both less thans without the equal to, so those are going to be open or closed circles. Open. I'm going to shade in the middle. Interval notation, that looks like negative 6 on the left to 2 on the right. They're both open circles, so we use parentheses or brackets. Parentheses. Alright, that does it for this video. Don't forget to do your My Math Lab homework to be ready for class, and we will see you in class. Thank you.